Hi guys, today we're going to be talking about deforming the Earth's crust. We've already talked about this a little bit when we had two sides of crust that were being squeezed together and it forms those ripples in the middle. We talked about it in terms of rocks and the up and down kind of squiggly lines that it makes when those horizontal rock layers get disturbed. So we're going to kind of build on that today and talk about the different kind of landforms and things that we can get when Earth's crust is actually deformed from different kinds of stresses. Okay, so the first thing we're going to do is review a little bit. So we have right here a divergent plate boundary where two oceanic plates are pulling apart. That gap in the middle is called a rift valley, and when the magma comes up and makes volcanic mountains all along that rift valley, we get what's called a mid-ocean ridge. So if you'll remember, this is the place where seafloor spreading happens, and we get brand new seafloor where that magma comes up and cools and forms brand new rock. This middle picture here is showing you a transform plate boundary. Nothing's coming together, nothing is pulling apart. These two plates are simply sliding past each other. Now, the edge right here in between the two of them is going to be jagged rocks, so they're going to catch on each other, and when the rocks snap and break, that's when you're going to get an earthquake that happens. Our third plate boundary is a convergent plate boundary. It's where those two plates push together. If you remember, we have three kinds of convergent plate boundaries depending on what type of crust we have, either oceanic or continental crust. So in the picture that you're seeing, it looks like it is two continental crusts that are coming together. Actually, strike that. It looks like it must be an oceanic continental because one is sliding under the other. But you can see this plate here is going under. You're going to get a bunch of friction. Remember, going under is called subduction when it's sinking. You get friction that heats up these rocks. Those rocks melt and turn to magma, and the magma works its way up to the surface and gives you a volcano. Okay, so the top one is seafloor spreading, and then you have the San Andreas Fault in California. This is actually a picture of the San Andreas Fault, and you can see that the fault line runs where the dotted line is. You can't see it just with your general eye, but that's where the fault line is, and this fence used to line up, and when those plates moved, it made the fence offset. Okay, so we talked about subduction as the other word for sinking. That's where subduction starts to happen, where the arrow is. All right, so let's review the convergent boundaries. Remember, we've got two types of crust. We have oceanic crust, which is more dense. Whenever it hits anything, it wants to go down. We have continental crust, which is less dense. It's lighter in weight, and so anytime it hits something, it tends to rise up and over. So the first one we have is the ocean continental. So ocean hitting the continent. The oceanic plate is going to sink underneath the continental plate. That's subduction. So you're going to get melting here from the heat and friction. The magma is going to work its way up. So all these mountains that you see right here are actually volcanic mountains. The second one is the ocean-ocean collision. So it's an oceanic plate coming together with another oceanic plate. Remember, oceanic plates are heavy and dense, so when they hit each other, they sink. So you get the subduction happening right in this zone. Friction happens, heat happens, it melts the rock. The magma works its way up, so these little islands that you're seeing right here are also volcanic islands. Okay, remember too, one thing on these first two, when you have the sinking, the subduction happening, it forms that underwater valley called a trench. So that's where we're losing ocean floor and destroying it. It's going back to the mantle and going away. That's the opposite of what is happening at a mid-ocean ridge where those plates are pulling apart and new seafloor is being formed where the magma comes up and cools. Okay, and then the final convergent boundary we have is a continental-continental collision. Continental plates are light and less dense, so they rise up and over. So as they hit, they're going to rise up, and these are going to form just plain old mountains. There's no magma here because nothing is sinking. You have to have subduction happening to get magma to form. So that's not happening here. They're just hitting and buckling, and both of them are rising up and forming just plain folded mountains. Okay, so you have to have stress acting on those different kind of boundaries. So what we're going to do now is attach the name of the stress to the different types of boundary. So deformation is the process by which the shape of a rock changes because of stress. So compression is the first type of stress that we have. It's when rocks get squeezed together. So that's when, like the arrow shows, you have two pressures coming towards each other and squeezing everything together. This happens at a convergent boundary. And again, if you look at the arrows and those arrows were plates, then you would see that they're about to hit each other and collide. So compression goes with a convergent boundary. Tension is the second kind of stress. So this is when you pull rocks apart, and in the center it gets skinnier and skinnier and skinnier, almost like pulling a piece of bubble gum apart. So you get that little thin little area that's in the very center, and if you keep pulling it, it's going to break. So tension is where they're pulling apart and being stretched, and that happens at a divergent boundary. Again, if you look at the arrows, the yellow arrows, and assume that they're plate boundaries or that they're actual plates pulling apart, you can see that that is a divergent boundary where magma would be able to come up through the middle in that rift valley. But tension is the stress that pulls apart those rocks at a divergent boundary. So shearing is the third one. So we've covered compression for convergent boundary. We've got tension for divergent boundary. Shearing is what goes with a transform boundary. It's that side-to-side slicing motion. So you've heard of scissors. The fancy name for those are shears. So it's because they have the slicing side-to-side blades. When you cut with scissors, those blades literally slice side-to-side motion. So that's the motion that's happening, or the stress that's happening on a transform boundary. Okay, so we have talked about folding a little bit already, again, when we were talking about relative dating and how rock layers, when they're undisturbed, they're straight. If they have a stress acting on them, then they can kind of buckle and curve. So we saw rock layers that looked like this, where they were kind of rippled. So now we're going to name the ripples. If it is a ripple that goes up like a hill, it's called an anticline. You can think of it kind of like an uppercase A goes up like this. And then a syncline goes down. So think of a syncline almost like a valley. So the anticlines and synclines together make that whole S-shaped pattern that you see when rocks become stressed and buckled. A monocline is sort of a sideways motion, so you see it kind of goes here and then it drops down and then goes straight again. So it doesn't have the up and down anticline and syncline. You have a little dip right here and then it levels off. Okay, so this is going to give you a little bit of a glimpse into what we're going to talk about after her break when we get to earthquakes. So faulting happens to be the crack that are on plate boundaries between two plates. And they can take on different shapes and move in different ways depending on if they're a convergent boundary, divergent boundary, or a transform boundary. So we have a different type of fault that goes with each type of boundary. Before we get into that, two of the three faults have what are called hanging walls and footwalls. And it has to do with the shape of the side that you're dealing with. So this one is at an angle where this little person can hang off of the edge. It has nothing to do with how high or low it is in elevation. It has everything to do with a simple shape. So they're able to hang off the edge. So this whole side is called a hanging wall. This side on the left is called the footwall. And you can remember that because this little hiker here could theoretically climb up and run up the side of that wall. So that's going to be important when we get to the different kinds of faults because the hanging wall and the footwall slide up or down. Okay, so again, we have three different kinds of plate boundaries, so we're going to have three different types of actual faults, earthquake faults, that go with each of the boundaries. So in the case of a normal fault, notice the hanging wall and footwall. It has nothing to do with the height that you're at. It has everything to do with the shape. Here's the corner that you could hang off of, so that right side is the hanging wall. But in the case of a normal fault, you see the black arrows. you have tension pulling those plates apart. So because tension's pulling them apart, it allows the hanging wall to slide down the foot wall. So the hanging wall goes down, the foot wall will either stay in place or go up. And so this is the shape that you end up getting. Notice that the crack is not vertical, the crack is actually a diagonal crack. So this is one plate and this is the second plate, and they're pulling apart. When these move, again, rocks are going to break as they shift and slide, and every time they break, you're going to get a shock wave that we know as an earthquake. So a reverse fault, first of all, if we look at the black arrows, you'll notice that they're pushing together. Well, the plate boundary that we have, where two plates are pushing together, is a convergent boundary. So this is the type of fault that you get with a convergent boundary. So in this case, the hanging wall, notice the edge that you can hang off of here, the hanging wall has now gone up and over the foot wall, because when they squeeze together, it slides up that diagonal angle of the actual fault crack there. So it's going to go up and over. And again, when the rocks break, as it moves, they send out shock waves, which we know as earthquakes. So this is compression, squeezing together. That's your stress. It goes with a reverse fault, and the reverse fault is formed at a convergent boundary. So these three things go together. Reverse fault, compression is squeezing it together. It's at a convergent boundary. Okay, so we have done divergent boundaries, we have done convergent boundaries. The only one left is a transform boundary. So a strike-slip fault is what goes with a transform boundary. Notice here we have the two sides. Here's our fault line right here, is that crack, and they're just simply sliding past each other. This used to be a road that lined up, but over time, as the plates have moved and shifted along that fault line, this one has shifted down, this one has shifted up, and that road no longer lines up. So you saw earlier in the PowerPoint that the fence line didn't line up. That actually happened in real life. That is a real picture. So it's side-to-side stress called shearing. There is no hanging wall and foot wall. You'll notice that the crack is a vertical crack this time. This is what's happening out in California for the San Andreas Fault. Nothing is sinking, so we don't get any subduction, which means we don't get any magma that forms. Therefore, we get no volcanoes. So that's why California just has earthquakes and not volcanoes to go with it, because nothing is sinking. Okay, last thing here, mountain building. So we have already talked about folded mountains. Again, it's when you have a continental collision. They come together and the mountains go up because continents are less dense and they rise up and over. So there's no volcanoes in here. These are just plain old folded mountains where they hit and the crust buckles and goes up. Now, fault block mountains is when you have areas that slide down, tensions pulling these rocks apart. And when they pull apart, these areas slide down. And you see they kind of go off at an angle a little bit. But they're not formed because something is rising. They're forming because this area is going down, which makes this look like a mountain. Okay, and then volcanic mountains, that's anytime magma is going to be able to find its way to the surface, it's going to cool and form a volcano. And those volcanoes will erupt as long as there is magma underneath it. Once the magma goes away, then those volcanoes become extinct and they will no longer erupt. Okay, make sure that you have your notes paper to school tomorrow so that it can be checked, and have a wonderful night.